Pittsburgh, April 1869. A train rolls out of a tunnel under Grant's Hill. The engineer, Daniel Tate, sees a horse-drawn wagon on the track ahead. He has maybe 4 seconds. He grabs a valve. The train stops in 10 feet. That moment did not make the newspapers. The man who built the valve was 22 years old, largely broke, and had spent the last year being thrown out of every office that mattered in American railroading. The most powerful railroad man in the country had already told him, to his face, that his idea was nonsense, that the very notion of using air to stop a train was the sort of thing only a fool would propose. Cornelius Vanderbilt was wrong about George Westinghouse, and the cost of that mistake was paid in blood for the next 24 years. If American Ironworks has documented anything across this channel, it is this. The men who built the machines that moved America were rarely the men who controlled the institutions that deployed them. Subscribe to American Ironworks and watch what happens when those two forces meet. Before Westinghouse filed his patent, stopping a freight train required a specific kind of man. He was called a brakeman. His job was to ride on top of the train. When the engineer blew the whistle for brakes, the brakeman ran across the catwalk, the narrow wooden plank on the roof of each freight car, leaping from car to car while the train moved, turning a heavy iron wheel on each one to press brake shoes against the wheels below. He did this in rain, in ice, at speed, in the dark. The men who survived 7 years in that job were considered exceptional. Scribner's magazine documented the annual toll in the 1880s. 1,000 brakemen killed every year and 5,000 more injured, not across a decade, per year. The railroading journals ran poems about them. One appeared in the Locomotive Engineer's Journal in 1885. It was called Only a Brakeman. The catwalk had telltales, poles hung with rope at low clearance points along the right-of-way. When a brakeman felt the rope brush his face while running across the roof of a moving car, he had seconds to drop flat before the bridge or tunnel entrance overhead took him. The rope was not a safety measure, it was a warning. The other structural problem was simpler. A train going 15 miles an hour required several minutes to stop. Engineers could see a wreck forming ahead of them and still not stop in time. A single track with 2 trains on it and no way to halt either one was not a design flaw. It was standard American railroading. George Westinghouse was 21 years old when he watched the aftermath of a head-on collision near Troy, New York. 2 engineers had seen each other. Neither could stop. He had recently invented a device for guiding derailed cars back onto the tracks. He held a patent for a railroad frog, the steel casting that lets a train switch between tracks. He was selling those inventions out of a shared office space, working for a Pittsburgh steel supplier named Anderson & Cook, and he had been thinking about compressed air. Mining engineers in Europe were using compressed air to drive drills through rock, running pressurized lines hundreds of feet underground. Westinghouse looked at that and saw a railroad application. A compressor on the locomotive, a reservoir on each car, a single pipe running the length of the train. The engineer controls the air. The air stops every car at once. It was a clean idea. It took him about a year to build a working model. He took it to Cornelius Vanderbilt. Vanderbilt ran the New York Central, the largest railroad operation in the country, and did not ordinarily grant meetings to inventors arriving without appointment. Westinghouse was persistent enough to get one. Vanderbilt heard the pitch and delivered his verdict. Britannica records it this way: "If I understand you, young man, you propose to stop a railroad train with wind. I have no time to listen to such nonsense." Other sources have him saying something considerably less polite. The outcome was the same either way. Westinghouse was out. The Erie Railroad showed no interest. The New York Central declined to respond. Westinghouse went back to Pittsburgh, filed patent number 88,929 on April 13, 1869, and found a different route. Ralph Bagley owned one of the largest foundries in Pittsburgh. He had met Westinghouse the previous year and had some confidence in the idea. He backed a working prototype. The Pittsburgh, Cincinnati, Chicago, and St. Louis Railroad, the Panhandle Route, a Pennsylvania Railroad subsidiary, agreed to run a test. The terms were stark. Westinghouse and Bagley paid for the installation themselves, and they were responsible for any damage if the system failed. The test ran in the spring of 1869 on the Steubenville Division. Westinghouse put a compressor on the locomotive and ran a single pipe the length of the train, with a flexible coupling between each car. The engineer controlled it from the cab. One valve, every car. Then Daniel Tate drove the train out of the Grants Hill Tunnel and found the wagon. 10 feet. It took 4 months from the moment Westinghouse filed the patent to the moment he incorporated the Westinghouse Air Brake Company. The company launched September 28, 1869. Capitalization, $500,000. Among the original backers was a young Pennsylvania Railroad officer named Alexander Cassatt, who would later become the railroad's president. Westinghouse was named president at 22 years old and nicknamed by then Crazy George. Now here is the engineering detail that every competitor missed, and 650 British patents before Westinghouse had also missed. The original air brake used direct pressure. Add air, apply brakes. The problem with that logic is terminal. If the brake pipe leaks, the air escapes and the brakes release. A broken pipe means a runaway train. In 1872, Westinghouse reversed the logic entirely. His automatic brake held the brakes off with air pressure. The system kept the brakes disengaged by maintaining pressure in the line. A drop in pressure from any cause, a leak, a severed coupling, a broken valve, automatically applied the brakes. The train could not fail into a runaway. Any failure stopped the train. Think of it this way. A door lock that holds when the mechanism breaks stays locked. A door lock that opens when the mechanism breaks is a different machine entirely. Westinghouse built the second kind. Every prior inventor had built the first. By 1880, 2,211 American locomotives and 7,224 cars carried Westinghouse brakes. By then, the company had affiliates in Britain, France, and Russia. A 50-car freight train at 20 miles per hour that previously required 5 brakemen operating over 1,500 feet to stop could now be halted in 171 feet. The engineer did it alone, from the cab, in under 3 seconds. The railroads did not rush to equip their freight fleets. That is the number the boardrooms ran: $40 million to retrofit the nation's freight cars. Against that, the railroad industry weighed the annual cost of 1,000 brakemen dead and 5,000 injured. They chose to wait. An Iowa railroad commissioner named Lorenzo Coffin had watched a brakeman lose both hands in a coupling accident in 1874. He spent the next 19 years driving a single piece of legislation through state assemblies and eventually Congress. He did most of it alone. His peers called him a crank. On March 2, 1893, Congress passed the Safety Appliance Act. AIR brakes and automatic couplers were now federal law on every train in the United States. The deadline for compliance was 1900. The railroads negotiated 2 extensions before they met it. In 1893, when the act passed, fewer than 10% of American freight cars carried air brakes. By 1905, 89,000 locomotives, 2 million freight and passenger cars, 1,000 brake sets produced at Westinghouse's Wilmerding plant every single day. The Wilmerding plant sat 14 miles east of Pittsburgh, adjacent to the Pennsylvania Railroad main line. Westinghouse built the town around it. Employee housing was sold to workers below market cost. A hospital, schools, the first American industry to institute a half-day on Saturday. A disability insurance plan in 1869, when most employers had never used the phrase. His wage policy infuriated other industrialists. His workers stayed. The Wilmerding plant sat on 30 acres. The machine shop alone covered 9 acres of floor space. It produced 1,000 complete brake sets every day by 1905. The plant ran its own foundry and its own test track. The town of Wilmerding built up around it. Churches, a YMCA Westinghouse funded, row houses sold to workers at cost, the railroad running directly past the loading dock. He designed the brake, the factory, and the town simultaneously, every component in relation to every other, the way an engineer designs a system. By 1900, the companies Westinghouse had built employed 50,000 people across 61 operations. The air brake was the foundation. On top of it, he had built Union Switch and Signal in 1881, the Westinghouse Electric Company in 1886, a natural gas distribution business, and the alternating current electrical infrastructure that lit the 1893 Chicago World's Fair, the contract his company won by underbidding J.P. Morgan's General Electric. That is the ARC the history books give you. Before that arc closes, subscribe to American Iron Works. What comes next is the part the arc leaves out. In October 1907, a financial panic hit the New York Stock Exchange. Trust companies collapsed. Credit froze. Loans were called. Westinghouse Electric had borrowed to fund rapid expansion. When the credit dried up, those loans came due. The Westinghouse Air Brake Company had no debt. Morgan could not touch it. But Westinghouse Electric did. The board that Westinghouse had assembled forced him to take a leave of absence. By 1909, he had resigned as president. By 1911, he had severed all ties with every company he had founded. He died in New York City on March 12, 1914, at 67. In his final months, he had been confined to a wheelchair and spent part of that time designing an electric-powered version. His last patent was granted in 1918, 4 years after his death. Arlington National Cemetery. The man who designed a system where any mechanical failure automatically stopped the train had no equivalent protection against a called loan. His air brake worked because he reversed the failure mode. Pressure lost meant brakes applied. The system could not fail toward catastrophe. It could only fail towards safety. He never applied that logic to his own empire. He built Westinghouse Electric on debt and ambition and the assumption that the machines would keep running. When the credit market stopped, there was no automatic brake. Vanderbilt called him a fool. The institution that replaced him got to keep the machines. 89,000 locomotives, 2 million cars. Every one of them still stopping the same way Daniel Tate stopped that train in 10 feet outside a Pittsburgh tunnel in April 1869. The air brake is still federal law. George Westinghouse is not a household name. American Iron Works covers the men who built the machines and the institutions that outlasted them. Subscribe to American Iron Works. The next video in this series covers the other engineer who tried to change American railroading and what the institution did to him the moment he succeeded.